Hey everybody, you might want to scooch in just a little bit because I know it's like loud and there's pipes in here. Today we're going to be talking about using expressions for various things in Maya, procedural animation, using them as controls in a rig, using them to create like a camera shake type effect with the noise function, that kind of thing. Who here has experience using expressions or the expression editor in Maya? Okay, well sweet. This is going to be a lot of review. So, let me open up Maya. The first thing I wanted to go over is just like what expressions are. Since we got a lot of experienced people in the room, I'll be pretty quick. Basically, an expression is another way to make a connection in Maya that is evaluated every frame when you play your timeline, as opposed to like a node connection, which is evaluated whenever the viewport updates. Expressions are pretty useful for doing things that are based on math. Like the thing I see most is doing things that are based on the sine wave. And they're also, if you wanted just to relate one attribute to another, it's another way similar to a node connection that you can do it. They have their own editor in Maya, and they have their own scripting syntax. They're basically constructed via scripts. It's pretty similar to Mel, but simpler. I'm going to open up the expression editor. You can find it under Windows, Animation Editors, Expression Editor. And this is pretty much the UI. When there's an object in the scene, it'll pop up and it'll give you all of its attributes that you can click on, or you can just type your expression with the attribute and it'll assign it automatically. So just as an example, I'll create an expression on this very small sphere. First I'm going to scale it up. There we go. So I'm going to make an expression that every frame will just set this sphere's translate x to 10. And you would do that by typing in psphere1 dot translate x equals 4. It's pretty similar if y'all were at the Mel scripting meeting 2 weeks ago. Like, the syntax is almost entirely the same, and you do need a semicolon at the end. Just press create, and it'll do it. Oh wait, but earlier I said 10. That's okay. You can edit an expression by just changing it and editing it, and as long as your syntax is good, it'll just do it. You'll see that every frame, this thing is now 10, and now I can't mess with the translate x anymore because it's purple, it's being controlled by an expression. So this is pretty useless, right? Just setting a sphere to 4. I could do that in a channel box. This is where expressions come in handy because you can make them based on time. So what if I wanted this sphere to translate 10 units every frame? I would use the variable time, which you just type out time. 10 times time, and every frame this thing will, its translate x will evaluate as 10 times the current frame. So, beep, you can see it crawling. Pretty cute. You can see various things that would be useful for if you wanted to just not animate something, not put keyframes on something that just had to be constant. If you wanted to like make a bunch of things using a script and not put a keyframe on them all manually to animate that, it'd be a fun thing to use expressions for. You can also connect like one item's attribute to another using expressions, and I will show that. Let me delete this expression first. Say I have a locator, and whenever I move the locator up, I want the sphere to also move up, just sort of like a direct connection. So I will say that psphere1 dot translate y is equal to whatever this thing is named, locator1 dot translate y. Oh, that's one thing I forgot. Don't like switch onto another thing until your expression is done, because it will disappear, as you just saw. psphere1 dot translate x equals locator1 dot translate x. There we go. Now those are connected, and you'll see the connection via the purple thing in the expression editor. You wouldn't want to use expressions for direct connection type movement though, because they are messy. They are a little laggy in Maya because they evaluate every frame. So you more want to use expressions for procedural things that you wouldn't be able to get using a regular connection. So I would recommend against doing something like this where you're just directly hooking up translate X to translate X. You just use a direct connection for that. But it is a thing you can do, and I want to be educational. So I'm going to demonstrate sine function. Sine function is really nice. I kind of want to talk about the math of sine function for a sec. So I'm going to bring up a picture of it. Sine function is known as a periodic function, meaning it's a function that repeats every period it has. Period is a variable that defines the length of time a sine cycle is. And so it's useful if you want something to just go back and forth. By default, the sine will evaluate from -1 to 1. And so you can think of all the things that would be useful for it. It's basically just I want to animate from -1 to 1 with easing over time, over and over. I want this thing to float up and down. I want this thing to rotate over and over. It gets used in a lot of mechanical type motion, a lot of things in nature. Like you think about when a fish is swimming, one thing it gets used a lot for is an auto swim attribute on a fish rig. It's like spine chains are just rotating from one value to another with an offset over time, and it creates that waving effect. So I like to type out my sine functions actually not in the expression editor because it doesn't give you any like highlighting that a good code editor should give you so you can see where your parentheses are. I would actually recommend if you're going to type out a long and convoluted sine function that has a lot of variables, go into Notepad++. It's on every Monty computer and it's very good. So I'm going to just type out a basic sine function that you could put into the expression editor. Say, do we still have psphere1? I'll make another one. It's our good friend psphere1. And say we're wanting to control psphere1's translate y. We're going to make that equal to sine of time. Not sine of Tim, but sine of time. The way you could control this, right now this is only going to evaluate from -1 to 1, but a lot of times we're going to want to have it evaluate to a specific value. There are 3 variables in a sine function that control how it operates, and I'm going to label them as A, F, and O. A stands for amplitude. Amplitude basically defines the number, like it's a multiplier of sine function. Since a normal sine function is multiplied by an amplitude of 1, it goes from -1 to 1. If you changed your amplitude to 5, it would go from -5 to 5. It defines like the range. The variable f here is frequency, and that basically defines how long the period of the sine function is or how many times it repeats, like its speed. If you turn the frequency up, it's sort of like if you think about sound waves, it's the same concept. The frequency up will make it go faster, and the frequency lower will make it go slower. And offset is basically taking that sine wave and translating it to the left and right on that graph I was showing you. What we use offset for in animation and scripting would be to like you gradually increase the offset on each item, and it'll like offset them from each other and give you a successive breaking of joints effect, like an overlapping action effect. So the higher that number is, the more delay you'll have on whatever you're running your sine function on. For right now, if we're just doing one object, we don't really need an offset, so I'll save it for later. But I'll just say that I want the translate y of this sphere to go from like -50 to 50, so I have it go. And the frequency, I usually find 10 is a pretty good frequency. If we run this, I have a syntax error. Where are we at? I might have to do math.sine. No. Do I have a missing parentheses somewhere? Hold up. Maya documentation is your best friend if you're not sure about your syntax. So I would just Google sine function Maya expressions. Yeah, I swore it was just normal sine. Did I write out sine? No, I wrote sin. Let me just try this. Okay, that's working. I think I just had a parentheses error somewhere. Change the amplitude up to 50, see if that'll work. Now you can see it going up and down from like 50 to -50. And then I'll change the frequency up to 10. And it goes faster. Can you see all the things this would be useful for? Like, what if I had a piston that needed to go up and down? What if I had an object that needed to, like, scale up small and large, like, every second or something? Super useful. But you wouldn't want to be, like, going into the expression editor to edit these on the fly, especially if you were incorporating it into a rig. So what you often do is you make a controller, and that's going to control these attributes of the sine function. So I'm going to make a NURB circle that's going to be our sine controller. Modify freeze, sine control. And I'll go in here and add some attributes. I will add a float attribute that's going to be our amp, our freq, and our offset. So now we go into our expression, and instead of just putting 50, we put sine control using dot syntax dot amp. And then instead of putting 10, we put sine control dot freq. Now you'll see it's not doing anything, because right now our amplitude and frequency are 0. If I turn this up, there we go. And you can totally like keyframe animate these too. Like, what if we wanted to have this guy like suddenly speed up and start shaking? I'll set a key here with a frequency of 0, and here with a frequency of something crazy like 100. And you'll see this thing just starts shaking. And now I'm gonna demo the offset function you really sort of need like multiple objects in order for the offset to show. So I'm gonna make like 3 spheres. I know my grid is really small. It's because I've been working with Unreal Engine proportions, so it's not my fault. Okay. Now we have 3 spheres. And I'll turn these back to 0 and delete those keys just so we don't have any craziness happen. And even if you don't have a sphere selected, you're still able to access its expressions by just writing out its name. So I'm going to actually like write out all these expressions for all these spheres on one sphere's like slice in the expression editor. P sphere 1 dot translate y is equal to sine control dot amp times sine of time. And then we have to, there's a lot of parentheses you gotta put in, because you have to make sure your order of ops is correct. So I'm going to do in this set sine control dot frequency times time plus 0 times sine control dot offset. And you'll notice this offset, it's not going to do anything. I'm multiplying it by 0. But I'm writing it in because it's that number, that multiplier, is going to increase for every object that gets that offset. So for the next one, I'll end up just copy pasting this function and putting in 1 times sine control dot offset. And the second one will get 2 times sine control dot offset. Copy this and I'll create this expression, and I gotta make sure, yep, you're smart. I've been writing in Python, which doesn't need semicolons, and so when I have to come back into this mel-ish syntax, it like busts my brain wide open. Okay. We'll just make some slight edits to this so that it'll affect the correct spheres with the correct offsets. Cannot find procedure sine control.amp. Oh, it thinks I'm doing a procedure. I forgot to put this multiply thingy. There we go. So now, amplitude 50, frequency 10. That's working like normal, but as we turn the offset up, it actually has to go into the negatives if you want to get like a normal looking offset, or in your expression. I think, yeah, I'm actually going to just edit the expression so that we're subtracting. And then we'll be able to use positive values for that. Turn the offset up to like 0.2. Get a load of that. So cute. 0.4. You get an offset in the sine wave, and so you get that sort of wavy function that you would expect out of something driven by sine wave. And you could keep doing this. You could like make a million spheres and get this really beautiful wave. And if I wanted to turn the amplitude up, you can totally control it using this controller. Super nice, super useful. I use it for all kinds of things. I made like a prehistoric slug the other day out of sine controls that was driving lattice points, and it was amazing. You can use a sine control to drive anything. Like if you wanted to drive rotation, if you wanted to drive scale, if you wanted to drive the translation of a cluster, if you wanted to drive a set driven key, that you just wanted like you have a blend shape and you want to like sine wave the blend shape for like something that's breathing, or There's literally so many applications of this that I could play with it all day and not get bored. Alright, there's one other periodic function that I wanted to talk about that's not sine wave that you can control with expressions that I think is pretty cool and doesn't get talked about as much, and that periodic function is called noise. It's based on a concept in computer graphics called Perlin Noise that is super cool and gets used a lot in texturing, but not so much in rigging, but we should think about using it more often because it's cool. The basic noise function will do this. Basically, I'll say I want this thing to like scale randomly. I'll do the scales. P sphere 1 dot scale x equals. You just type in noise time because noise is a function. It's like a function that runs. It's not a multiplier or anything. And I'm going to do this for all the scales so that they line up. And what this will do is sort of just make it scale like randomly, but it doesn't jump. It has like a gradual gradient. And that's because what it's based on, I'll show you what a map of Perlin noise looks like. Basically, Maya is taking an image like this that it's generating randomly based on a function, and it's using black as 1 and white as 0, and evaluating it over time as like it like runs through this map. And so you can see there's like nice gradients, so it'll go like gradually from 0 to 1, or only go from 0 to 0.2 or something. It'll just be random, but in a manner that feels natural. You see this a lot if like people will use Perlin noise to make a like random landmass texture where like 1 being above water and like 0 being below water, and you'll see like little mountains rising out of the lake, and it's super cool. And we can use it to shake things around or scale things randomly. And this function has a period and a frequency and an amplitude, just like sine does. It doesn't really have an offset, although I'm sure there's a way you could hack it in. Your amplitude, you will multiply it. So say I wanted this to like be way crazier. I could just do 50 times noise time. Yeah, and you'll see this is kind of insane. I'll scale that back a little bit for demo purposes. And then if you wanted it to just go way faster, you multiply your time variable by frequency. So in this case, I'll multiply it by 10. Yeah, can you see how this would be useful? I've seen people use it for like, if they wanted a shaky cam, they could use a noise function to sort of just gradually shake the camera around randomly, but within like a set parameter, so that it doesn't look crazy and it's not like jittery and jumping around. That's basically all I had on expressions. I hope you learned a little something, because I think they're super useful and super fun to look at. If anybody's got any questions, just raise your hand and I'll take care of it.